Hello everyone. In this video, I'll demonstrate how to monitor a particular service running in a server using Raspberry Pi Pico W and control the status of an LED based on server availability. You can see the model here. It is Raspberry Pi Pico W 2022 model. This is connecting to my network over Wi-Fi and monitoring this particular server. Here I'm running Apache 2 service. If I turn off the service, so this LED will turn off and you can see the status here. Web server is down and I'm using microcontroller socket library for monitoring this. Let me turn on the server again. This is a very basic script, but this allows your Python code to interact with physical devices and gives endless opportunity for automation and customization. Here in this example, we are controlling an LED, but you can apply same principle to control any supported GPU devices. The reason why I chose Pico W is because it is a low-cost microcontroller with wireless support. This costed me less than $8. So this is a good board to start with. Before we start coding, I'll walk you through some of the Raspberry Pi boards which I am having. This is Pico W. This is having inbuilt Wi-Fi antenna, but this supports only 2.4 gigahertz. You need to remember that. This can even act as a soft access point which supports 4 clients. All those configs we will see later. This is having dual core ARM processor with 133 megahertz of clock speed and 2 MB of onboard flash memory. And there you can keep the Python files. And this is Raspberry Pi Pico. You can see Pico 2020 model, and both are having same specs except this doesn't have the Wi-Fi capability. So this cannot connect to network, and this costs around $4 and this is around $8. And this is Raspberry Pi Zero W, and this is having processor with 1 gigahertz of clock speed and 512 MB of RAM, and this is even having a micro SD memory card slot. You can install operating system there. I have installed 𝗨𝑽𝑜S there, and this even supports Wi-Fi and Bluetooth. Then here we have a mini HDMI port for display, and second port is micro USB port where you can extend to keyboard and mouse, and third port is power port. And in these models you can see a boot cell button, and if you long press this and connect USB port, this will get into mass storage mode and you can change the boot image. Then this is Raspberry Pi 4B. This is like a mini computer. This is having gigabit Ethernet port, 2 USB 3 port and 2 USB 2 port. Here even we have audio port and 2 micro HDMI ports. This is having 1.5 gigahertz processor, 4 GB of RAM. You will even get 8 GB RAM model. This cost more than $100. Now let us get back to the terminal and start writing code for all these boards. First, we need to install boot image into Pico W device. You can download the boot image from Micropython website. You can download any of these image. This will be 1.4 MB in size. Once you download it, while connecting power to the device, you need to long press this boot select button. Then this Raspberry Pi board will show as a storage device, removable storage device in the machine. Then you can copy paste this particular file. Then it automatically resets and loads Micropython. To access the terminal, you need a software called Tony. This is the recommended IDE for Micropython. I have already copied and installed the boot image and it is loading here. To install this particular software, Tony, you can go to this website. You can see the command here, sudo apt install Tony. So once you install it, you can make sure the device terminal. From here, select interpreter. I have selected Micropython generic, and board is in FS mode. FS means full speed, and communication device class is ACM0. You can verify this also from the terminal. If you give ls/dev/py, and here we can see ACM 0. ACM stands for Abstract Control Module. This is a generic term used for devices which provides a serial connection. And if I disconnect the Raspberry Pi from this machine, this particular ACM 0 will appear. I already have connection to the Raspberry Pi device. Now this is the Python terminal. From here, if you want to see the list of modules supported, I can give help modules, and by default all these modules are available, and all these are the lightweight version of the actual Python library. You can see uTime. So this is the Micropython version of the time module in Python. usocket. There are multiple uJSON. There are multiple libraries available. In this particular video, we'll be focusing on network module because we are going to connect to wireless network. So I'll print dir of network.wlan. First, we need to import network. Yeah. So here we are able to see the methods available for network module. So we can connect, can configure it. If you want to configure this as an access point, then to disconnect from network, to get the interface config, to scan your Wi-Fi network, all these options are available. So let us start writing the code. Here you can see in the files, I have Micropython device file explorer available. So I'll create a file here. I will press Ctrl S and I'll select Micropython device and I'll give the file name main.py. You need to give main.py as the file name so that whenever the device boots up, it will automatically load this file. And all the libraries you need to put it into lib folder. You can create even a lib directory here. And here I'll import network. And in this video, we are not going to handle the reconnect or the Wi-Fi connection failed scenarios. We will just directly go and connect to the Wi-Fi. Here I'll create a variable SSID name to, let me go to the wireless access point. So this supports only 2.4 GHz, this particular model. I'm logging into the access point. I'll click on enable. I will enable this particular SSID. SSID name is going to be 𝑝cow. And let me go to money here. I'll give this and SSID password. I'll copy from here. And before even connecting to SSID, we can scan the network. That is an optional step. And let me open the documentation of the network module in microcontroller, Micropython. So here, first we need to create an object, the WLAN object. So then we need to give active, then connect to the SSID. We'll write the code here. I'll create an object here, WLAN equal to network dot WLAN, then network dot 𝑠TAIF station interface, then WLAN dot active. I haven't enabled the SSID. Before that, we will do a scan and check whether this particular SSID is available or not. We need to activate it. Then we'll create a variable scan data equal to wlan dot scan. Then here we will be getting a tuple with the entire all the SSID details. Print and data, and I'll just print only the 0th element because I'll be getting a lot of SSIDs here. So let us try running this. Here we need to give wlan active true. And you can see the documentation here. Active true. I will save this and run the script. This is not needed for now because we are not connecting. We just added the variable. You can see here, this is one SSID available. And like this, you will be getting multiple SSIDs. And if you want to check whether a particular SSID is there, we'll try to scan whether this SSID is already there. We can do a for loop in this particular tuple, list of tuples which we are receiving, and then there we'll do a condition check. So I'll create scan status equal to, I will use any function. This is an optional step. This is not needed. For SSID in the scan data, the list of tuples which we are receiving here, so we'll be storing that into SSID. And you can see here, this is bytes data, so we need to check this using decode. So SSIDs, the SSID name is coming as the 0th element here, 0 dot decode is equal to, we'll check for this particular SSID name. I'm using comprehension here. Previously I have created a couple of videos on that. You can have a look into that to understand this logic. Then this will be returning true if SSID is already present. I will print the scan status and let us try running the script. So we are getting false. Now we'll enable the SSID. So I have selected 2.4 GHz because this supports only 2.4 GHz. But if you see Y4B or 0W, that supports even 5 GHz. I'll click on save. Now we'll go and run this again. So now it is coming. That means SSID is available. This is an optional step. I just wanted to show the scan functionality. We can comment this. Now we'll see how to connect to the SSID. For connecting to SSID, we need to give wlan dot connect, and within connect function we need to give SSID name. We are passing the variable SSID password. Here I'll do a print. connecting to SSID. And after connecting, we can check whether connection is successful or not. We'll do a print of WLAN dot is connected, and we'll print WLAN dot IF_config. And it might take a couple of seconds to get connected because we are using DHCP and IP should get assigned. So after connecting, we will wait for 5 seconds, import queue time, dot sleep 5 seconds. In the later videos, we'll handle all the failure scenarios, and if Wi-Fi is not available, this will retry a couple of times, or if authentication is failed or due to any other reason, if Wi-Fi connection is failing, it will try to reconnect. All these scenarios we'll handle later. Now I'll save the script. We'll try running again. It is trying to connect to SSID and waiting for 5 seconds, and you can see I have received an IP. We'll go and verify this in the network map. I'll click on clients. So here we can see 𝒂𝒊𝒂𝒔𝒕𝒊𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂 network, the guest network, and this is the laptop which I am using. Its IP is 0.35. Now we'll try monitoring a particular service running in this machine. I will try running Apache web service here. Let me open the command for that. Yeah, here I will start the service, and before that, even we can try pinging to the 𝒂𝒊𝒂𝒂𝒂𝒂𝒂𝒂𝒂 base from here. 192.168.0.101 is the IP. We are able to reach it. And if we disconnect this, I'll give WLAN dot disconnect. This will get disconnected from LAN. And now if we ping, this won't be reachable. Now if we run the script again, it will get connected. Now let us start writing code for monitoring the port number of this machine, 0.55. First, I'll import usocket. Then here I'll create a function, port test, and here I will pass the argument IP and port number. We'll introduce a try so that we can handle the failure scenario. If connection is failed, we will print web server is down. Object here usocket dot socket. Then we will try to connect to the particular IP and port. For that, we'll do this dot connect, and inside that we need to give the IP and port as a tuple, the comma port. In the end, we need to give close connection. This is having very limited memory, this particular device, so we need to close the connection. Here we will return web server is up. Now we can try running this. We'll say while WLAN dot is connected. If wireless is connected, we are going to get true. We'll do a print port test, then here I'll pass the IP 192.168.0.55 and port number is 80. Here we'll introduce a delay also in each test. So here I'll do a print. Wait for 1 second, then u time dot clip, and I'll give 1 second here. Now we'll try running this script. Here we haven't added except, that is why script is failing. What we can do, we will comment the try. That is connecting to SSID. Later we'll introduce except. So web server is up, but we haven't handled the not reachable scenario. For example, here if I give top, we are getting connection reset error. So this is an exception. So we will add try here, then except. Here we'll give return web server is down. In the next video, we'll see how to add the LED control here. So let us try running this. This is getting connected and it's saying web server is down. Now let me turn on the server. So now it is up. In the next video, we'll see how to control the status of LED light based on the server availability. We will add one more function for controlling LED light. I hope this video was helpful for you to understand how to connect a Pico W device into Wi-Fi and scan a particular port of the server. Thanks for watching. See you in the next video.